Hello viewers, welcome to you in Autonomous College. Today we are going to discuss about a new concept and is a part of session 2, and that is known as conversion of NFA to DFA. Because you know that in NFA concept we have lots of merits as well as some demerits. Still we need to change it, that means to convert to DFA part. That's why we have some steps which are required to conversion that NFA to DFA. Now we can focus on a slide. In this section we are going to discuss what are the different ways to convert some part of that NFA to DFA. In the outline about this topic, first of all we can also discuss what are the different procedures which are related to our NFA to DFA conversion. Then we are learning what are the different examples are related to our topic, because the part 2, in that part 2 we are learning more examples of this conversion technique. First of all we can focus on some parts of that is known as a conversion steps. So in this section, in the first step we are learning how to convert like NFA to DFA part, because you know that NFA stands for non-deterministic finite automata. So in that non-deterministic finite automata can accept some null relevant strings as well as null partial elements. So we need to convert this null element to normal DFA part. That means that DFA never accept any null strings, or we can say that is known as empty string. So instead of this string we need to design a DFA part. That's why we need to follow up some steps. So generally in this slide we have 4 steps. In the first step we are taking like initially Q dash. Q dash is known as a collection set, and we have one phi. Phi is another type of set which is denoted as an empty state, but in that empty state we never contain any type of flow in that activity. So in the second step we can add Q0 of NFA to Q dash. So in that part we need to find the transitions from this start state, because you know that whenever user want to doing any type of transitions, means the changes in the movement of the formation of the diagram. So in that movement we need to create some starting state that is known as initial state. So in that initial state we need to form one graphical representation. So we always to contain some states like our that is not Q0 and the transition and the terminal, whatever we can say. In the step 3 we are learning that is known as Q dash. In that Q dash find the possible state of states and for each input symbol. If this state of states is not in Q dash, then add it to the Q dash. If any type of transitions are created but the transition is not happen in the case of normal transition diagram, in that time we can add that step in Q dash. Q dash is known as a newly created state. So in the step 4 we are going to create one concept that is known as a DFA part. In the DFA part the final state will be all the states which contain F, because you know that F is known as a collection of some final states. Whenever user want to create more than one final state, it can be located in like F. F is a state which is a collection of more than one final state, because you know that in the case of NFA we have more than one transitions, because user can create more transitions by accepting more than one input symbols, or you can say same input symbols can be used for more than one states. That's why we need to convert to DFA. In the case of DFA only we can contain a single state movement in a single input symbol. So if a user want to design this type of diagram, we must follow these 4 steps. According to that 4 steps, we are generally getting a final state diagram, and that state diagram is known as a deterministic finite automata. So we can focus on the next part, that is the example which is denoted as to convert NFA to DFA. We have given a diagram. In that diagram is known as that is a part of NFA diagram. So this NFA diagram need to convert to DFA part. But how to convert this NFA diagram to DFA? So we need some procedure. First of all, user must to design a transition table. If a user can design a transition table from that transition diagram, which is already displayed in this slide. So in this slide already we have 3 columns. In the 3 columns, first column denoted as a state, and second column have an input symbol like 0, and the third input symbol like 1. So these 3 columns used to create a transition table. So in this table we have some state. So that is a collection of state. We need to form a diagram according to that table. So in the first state, that is known as Q0, that Q0 is known as initial state. So in that initial state must take a input symbol 0. In that moment it can create two states, and that is known as a Q0 and Q1. Whenever user can put a input symbol like 0 to Q0 state, in that moment we can form a Q0 already shown in the diagram. Whenever user can put 0, we can getting Q0, as well as whenever that Q0 can taking a input symbol like same 0, then it can form another next state that is known as Q1, which is already mentioned in this diagram. Similarly, whenever that Q0 can take input symbol 1, then it can create a state which is known as Q1 state, which is already mentioned in this table. Next, that is known as a Q1. Here, that Q1 is known as a final state. We know that whenever that final state is always denoted through star mark, or we can say asterisk. So because each and every type of final state, that is always denoted through double rounded circle, and each and every double rounded circle is always marked as a star, or we can say asterisk. Whenever user want to design its state chart, in that moment user can put input symbol 0, then it can create a state that is known as a phi set. Phi set means when, because that Q1 never take any type of input symbol like 0. Whenever that state never taking any input symbol like 0, in that moment we can create a state that is known as empty state, and that empty state is always denoted through phi. So here the phi is known as empty state. Similarly, whenever user can put 1 to Q1 state, in that moment we are getting two state, that is known as self state, another known as Q0 state. So in this way, this two state is denoted through by taking one input symbol. So it can be located in this table like Q0 and Q1. That means user can put one input symbol to Q1, it can create Q0. Whenever user can put same one input symbol to Q1, then it can create Q1 state. So it is a general way through which you can create this transition table. So next we are going to discuss what are the different ways to follow up to create this DFA part. So in this slide we are doing some transitions activity, and this is known as the explanation activity of a transition state table. So here now we will obtain that is known as a transition dash. Here transition dash is always denoted as a Q0 for the state, because we know that it is known as a Q0 is no initial state, because we are going to create a DFA part. That's why we are taking transition dash. Transition dash is known as a one formation step to create a DFA section. So here the transition dash contain a state initial state that is known Q0. Whenever user can put Q0 with the input symbol like 0, in that moment we are getting Q0 and Q1, which is already shown in our transition table, that is known as Q0 and Q1, which is known as a new state generated, which is already followed in this slide. Next, whenever user can put 1 to state Q0, in that moment we are getting a transition, and that transition is denoted through transition dash, that is known as a delta dash. In that moment we can create a state, and that state denoted as Q1. So whenever user can create that Q1 state, in that moment we are forming a one state chart. So if a user want to design this structure, we never follow any type of other activity. So here, like the transition dash for the state Q1 is obtained as, that is known as transition dash Q1. Whenever taking 0, it can create a phi, because you know that whenever no state is created after taking any type of input symbol 0, in that moment we are getting a state that is known as phi, because that is the phi is a part which is helps to create denoted as an empty state. That means is never taking any type of state diagram. So if a user want to create another state formation, in that moment that is known as a transition dash. In that transition dash, that is contain two state, that is known as Q1. Whenever user can put that Q1 with one input symbol, in that moment we can create two state, that is known as Q0 and Q1. We know that in the previous slide already we have taking like Q0 part. In that Q0 part can taking Q0 and 1 whenever it can create taking input symbol like 0. Similarly, it can take in 1, it can create Q1. And that Q1 also taking 0 as a phi. Whenever that Q1 taking 1, in that moment it can create two state like Q0 and Q1, which is already mentioned in this section here, like that is Q0 and Q1. Whenever 1 is put to Q1 state, which is denoted through transition dash. Now we will obtain transition dash on like state to state Q0 and Q1. In that moment we need to make it as a union. User first of all to locate like transition dash with Q0 Q1 comma 0 is the input symbol. So here we need to break this combination Q0 and Q1. In that moment delta Q0 of 0, then union the delta Q1 of 0. So in this way we are forming two transition state. So in that two transition state must be taking some output section. So whenever user can put 0 to Q0, in that moment we are getting a state like Q0 and Q1. That Q0 Q1 is created from taking 0 at the state chart diagram, that is known as Q0. Similarly, whenever user can put 0 to Q1, it can create phi. Phi is a state that is an empty state because that Q1 whenever taking 0 it never create any type of state. That's why it is located in the form of phi. And any set combined with, or we can say union with, that is known as a phi or empty state, that is always denoted as a same state like Q0 and Q1. So it can be denoted in that way. So it is a general way we can design it, this transition state part. So next we are going to discuss what are the different another part which is related to taking 1 as an input symbol. It is similar with the previous section. Here same transition dash and Q0 Q1, then it can take a input symbol like 1. In that moment it is also break in two parts, that is known as a transition Q0 comma 1, and whenever that Q0 comma 1 can be created, then similarly another part should be divided like union of, that is known as transition of Q1 and 1, and two sections, transition state sections are created. Whenever these two sections are created, we are getting some state which is already mentioned in this slide. So whenever user can put 1 to Q0, then it can create a state like Q1. Similarly, that is union with like Q1, whenever take the input symbol like 1, then it can create a state like Q0 and Q1. So it is a general way of movement through which you can be create this section in the slide. So whenever that Q1 union with Q0 Q1 it can be create, that is known as Q0 Q1, because we have two Q1. In that moment we can only consider a single Q1 state in this section. So here Q0 and Q1 is designed from, or we can say created from, this transition chart explanation. So whenever that two state is created, then we need to make an explanation which is already mentioned in this slide. As in the given NFA, Q1 is the final state. We know that, which already discussed in the previous slide. Then in DFA, wherever Q1 exists, the state becomes a final state. That means we are getting some new state. In that state also we have Q1. And each new state is contain any type of state like Q1. In that moment it is also considered as a final state. So here we can mention this slide. Hence in the DFA the final states are Q1 and Q0. Whenever that final state, that is known as Q1 and Q0, in that moment that like your Q0 and Q1 can be considered as a final state. So here therefore set of final states like f equal to Q1 comma Q0 of Q1. That means one is a single state Q1, another is a double state but considered as a single state in the case of final state. The next slide we are going to discuss how to create like DFA transition table. So if a user want to design like DFA transition table, in that moment we are making this slide. So here also we have three columns like state, and we are taking input symbol 0, another input symbol like 1. So in that DFA formation we have three state, but here we have a one new state that is known as Q0 and Q1, but other states are already exist in the slide. But in this section we are creating one new state like Q0 Q1, but here Q0 is considered as the initial state which is already mentioned through like a arrow mark. So that is the symbol of initial state. Whenever user can put 0 in that Q0, it can create two state like Q0 and Q1. So it is created through input symbol 0. Similarly 1, whenever that Q0 taking 1, it can create a state like Q1. Whenever user can put 0 to Q1 state, and that Q1 is denoted through asterisk is known as a final state. In that moment whenever user can put 0 to Q1, it can create a phi. Phi is known as a one empty state, that is a null state, so which is created from that transition state. So whenever user can also put 1 to Q1, in that moment we can create Q0 then Q1, and this 2 state is generated from taking 1 as the input symbol to Q1 state. Another state that is known as Q0 Q1, which is created from the transition information, which is denoted through asterisk, because this state we have Q1 in it, that's why I am making asterisk. If a user can put 0 to this state, in that moment whenever Q0 Q1 state taking 0 input symbol, it can create same state like Q0 and Q1. Whenever we can also put 1, it is also create same state like Q0 and Q1, which is already mentioned in this transition table. So after designing this transition table, we need to design a transition diagram. If a user want to design a transition diagram, we can follow up some steps which already described in this section. Here we are going to design a DFA state. So in that DFA state we can design like Q0. Here Q0 can take an input symbol like 0. Then it can create a state like Q0 Q1, which is already mentioned in this diagram. So it is because it contains Q1, that's why it is known as a final state, which is located through double rounded circle. And whenever that Q0 Q1 also taking 0 or 1 input symbol, then it is self redirected, which is already mentioned in this top part of that state, that is known as 0. Whenever user can put 0 or 1, it is self redirected. According to that self redirected, it can create Q0 and Q1. If a user want to put 1 to Q0 state, in that moment it can create a next state that is known as Q1. Here that Q1 is known as a one final state, which already explained in the previous section. That's why it is always denoted through double rounded circle. Similarly, whenever user can put 1 to Q1 state, it can create a state like Q0 Q1, which is already directed in this section, which is already mentioned in this part, that is known as a 1. Whenever that 1 is put to Q1, it can create a Q1, Q0 and Q1. Whenever user can put 0 to Q1 state, it can create a phi set, and that phi set is not located in this diagram. So it is a general way to form a transition table, or you can say transition diagram, which is already explained in this slide. So if a user want to design any other part, that means that may be related to our conversion section, so it is also possible. So if a user want to design any type of input symbol, that may be directly we can take a NFA diagram, that NFA diagram is also converted to DFA. Similarly, if a user want to taking any type of regular expression or any string type value or a transition table, it is also converted to like our NFA to DFA part. So but here we are only taking as a transition diagram, and that transition diagram is used to convert from like NFA part to DFA part. In the next section we are going to design like that. Even we change the name of the state of DFA. If a user want to change the state name, which is already mentioned in this slide, in that moment also we can taking some variable, and that variable may be A, B, C, X, Y, Z, whatever we can take, and whatever variable we can take, instead of that variable we use like our state. If a user want to put this type of variable instead of this state like Q0 Q1 and Q0 Q1, in that moment we can put A, B, C. That means here input symbol A is denoted by Q0, input symbol B is denoted as Q1, and last but not least here C, and that C is denoted as state Q0 Q1. So it is a general way we can design this transition part to convert like in different name. The next slide we are going to discuss like how to create this variable as a conversion part like A, B, C, because you know that here in this slide we already mentioned like Q0. Here that Q0 is denoted as a form of A, and here that A is known as initial state. Whenever it can take 0, then it can forming like Q0 Q1. But here in the previous section already I discussed, Q0 Q1 is located as a C, because it, in the form of C is known as symbolic representation of Q0 Q1. That's a, instead of like Q0 Q1 we can write C, and it can taking two input symbol like 0 or 1. Similarly like Q1, and that Q1 state is denoted through B input symbol, which is already mentioned in this slide. So it is a general way through which you can be creating some final state, and each and every time final state is always located through double rounded circle. If a user want to designing this double rounded circle in the form of transition creation, we must follow this type of techniques or procedures. The next part, that is known as advantage, or we can say disadvantage of this conversion part. Here the advantage of NFAs over DFAs is the property to always choose the right path. If a user never taking any right path to conversion of this NFA to DFA, in that moment it creates lots of ambiguity, means some confusion at the time of conversion. So if a user can say in an algorithm to choose the right path, usually a conversion from NFA to DFA works. And creating DFA states that symbolize multiple NFA part, that is known as NFA states. So if a user never taking any type of states in the form of NFA to DFA, in that moment we are always aware about it. If a user not be aware about the right choosing of like state model, in that moment we are never getting the right consequence, and that right consequence is not in the form of DFA. That may be the partial form of DFA. Somehow it will be related to NFA. That means it is not the right, or can say proper conversion of NFA to DFA. So here we can say that finally when your NFA is in state A and has the choice to go to A, B or C, then the next state in your DFA would be A, B, C. So ABC is created from like your NFA part whenever user can taking this NFA conversion section. So in that NFA conversion section is never forming any type of diagram. If that diagram is not being created, in that moment we are getting a great error, because you know that whenever user never forming any type of error conversion section, so in this part we never getting in real consequence in the time of conversion. So this explains the advantages and disadvantages. DFA can be implemented easier since their next state is determined by a function. Now if it is not be easier, then we never getting the right consequence, because it is easier because we have a NFA part, and that NFA must providing some steps. By using the steps we can easily convert like NFA to DFA. Here NFAs allow a user to easier express what they want, because the NFA can choose between many paths. Because whenever user want to take like NFA, and that NFA is always taking easier expression, we know that, but what they want, because the NFA can choose between many paths. Whenever user want to design like NFA section, in that moment we are creating more than one states, or we can say state movements directions after taking in the form of NFA. But in DFA is always the case of finite. It is a limited way of creation. If a user is never aware about it, then we never right way to create a DFA section. So, and whenever user can design a right consequence of this conversion, in that moment that conversion may be one critical form of transition diagram. In the next, or we can say the next class, we are discussing how to minimize the DFA to, this is the minimal DFA part. So today we are only discussing about this conversion technique. So if you have any type of queries or request, you can send through our YouTube channel comment box. Have a nice day. Thank you so much.